All right, today we're going to be going over 2.6, which is geometric proofs. On Friday, we did 2.5, which was algebraic proofs. So this is along the same lines. It's just more with geometry. So the objective is to write two-column proofs and to prove geometric theorems by using deductive reasoning. The vocab is theorem and two-column proof. So write a justification for each step. Given that angle A and angle B are supplementary and the measure of angle A is equal to 45 degrees. So we need a justification for each step. So we have 4 steps here, and we are going to need 4 justifications. So let's look at step 1. What would be our reason, what we put on the right side, for step 1? We're looking at this. Angle A and angle B are supplementary, and the measure of angle A is equal to 45. So then the measure of angle B. That's the given. So this will be the given. On a test or quiz, never leave the proof blank, because you guys always know that the first thing is going to be the given. Okay? You always state the given first. And the reason is going to be given, because that's what's given to us. When I say given, I mean what's given to us in the problem. So now we have the measure of angle A plus the measure of angle B is equal to 180. How do we know that the measure of angle A and the measure of angle B is equal to 180? Because it says that they're supplementary. So this one would be the definition of supplementary angles. Now let's look at step 3. So we have 45 degrees plus the measure of angle B is equal to 180. How did we go from step 2 to step 3? What did we do? We filled in angle A. So we substituted angle A. So the step would be substitution. Now how would we go from step 3 to step 4? What did you say? Subtraction. So we subtract 45 from both sides. So since we're subtracting 45 from both sides of the equal sign, this would be subtraction property of equality. That's like angles, so I drew a little angle. That's just an abbreviation. So write a justification for each step. Given that B is the midpoint of AC and segment AB is congruent to segment EF. So what's our justification for step 1? Given. So B is the midpoint of AC. Segment AB is congruent to segment BC. So it's saying that AB is congruent to BC. How do we know this? Because it said midpoint. So step 2, our reason would be definition of midpoint. Now we have segment AB is congruent to segment EF. Where did we see this before? That segment AB is congruent to segment EF.
And then, is it given?
It's given. It was given to us in the problem. So the reason for this one would be given. Yeah. Usually, sometimes you can list the two givens, if it gives you two givens, or if it gives you more than one, you can list them both in step 1, but this one just listed it in step 3 to help you visualize it better. So we know that AB is congruent to EF because it's given. So now we can say BC is congruent to EF. What would our reason for that one be? Substitution, right? Because we can substitute. We know AB is congruent to EF, so we can substitute the BC in for this AB. And BC is congruent to EF. So this is substitution. We could also have another reason for step 4. If we said that segment AB is congruent to segment BC and segment AB is congruent to EF, then BC is congruent to segment EF.
Could it be the
Transitive. So step 4 could either be substitution or transitive. Transitive property of congruence. Any questions on this proof? So a theorem is any statement that you can prove. Once you have proven a theorem, you can use it as a reason later in proof. So remember, we have a proof that has statements and then reasons. So we can list our theorem on this side, on the right side of the proof. So theorems can be reasons for what we did on our steps for the left side. So let's take a look at these two theorems. The linear pair theorem. If two angles form a linear pair, then they are supplementary. So what does it mean to form a linear pair? Two angles on a line that are next door neighbors. So if they're both on a line, they equal 180. So if two angles form a linear pair, then they're supplementary. So you can add this angle plus this one and get 180 because they form a line. Let's look at the next theorem. Congruent supplements theorem. You don't necessarily have to memorize all the words, but you have to know how to apply them, which we'll go over examples where we apply them, okay? So what does the word congruent mean? The same. What does the word supplements mean? They add to 180. So if two angles are supplementary to the same angle, then the two angles are congruent. So angle 1 and angle 2 are supplementary. So what do we know about angle 1? Well, what do we know about the measure of angle 1 and angle 2 if they're supplementary? That they add to 180. And then we have the measure of angle 2 and the measure of angle 3 are supplementary. So these two add to 180 also. So let's take any number and we can plug that into the measure of angle 2. So what's an angle that we can plug in there? 10. So if the measure of angle 2 is 10, then what would the measure of angle 1 be? 170. Well, in this case, we have the measure of angle 2 again. So we know that one's 10. Then what's the measure of angle 3?
170.
170. So now the measure of angle 1 is equal to the measure of angle 3, because we said that those are both 170. So geometric proof begins with given and proof statements, which restate the hypothesis and conclusion of the conjecture. In a 2-column proof, you list the steps of the proof on the left column and you write the matching reason for each step in the right column. So we have 2 columns. This is what we've been doing on Friday and today. So on the left side, we have the statements or steps. And on the right side, we have the reasons, which the reasons are just explanations for what correspond to the statements. So on the next slide, we have a 2-column proof with statements and reasons. So we have to provide reasons for each statement on the left. So what would be a reason for step 1? Given. You're always going to list the given as the first step. And now we have xy is equal to xy. Reflective. Reflexive. Reflexive property of equality. Bless you. Now we have segment xy is congruent to segment xy. Well, we wouldn't write proof because we're trying to prove. So we need a reason for how we got from step 2 to step 3. So this is just the definition of congruent segments. So if you have 2 segments that are equal, then by definition, the segments are congruent. So remember, when you have equal, it's talking about the number, the length. But when you have congruent, it means that they're the same shape and size. So now we're going to fill in the blanks to complete a 2-column proof of one case of the congruent supplements theorem. So what does congruent mean? And what does supplement mean? They add to 180. So let's look at A in step 1. So we need to fill in this blank. What would we put as the first step? It says our reason is the given. So what would we put on the left side? 1 and 2 are supplementary, and 2 and 3 are supplementary. So we're just restating the given here. So we have angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary.
I just put 1 and 2 equaling.
Well, we don't know that they equal 180 yet, because in order to say they equal 180, we need a reason for that. So you're just skipping the first step. Remember, in the first step, you just rewrite the given. And your reason is given, because it was given to us in the problem. So now let's look at step 2. Francisco, what does step 2 say?
Angle 1 and angle 2 equal 180, and angle 2 and angle 3 equal.
Right, so what you said was step 2. And our reason is the definition of supplementary angles. Because it tells us that 1 and 2 are supplementary. And the definition of supplementary angles is that they add to equal 180. So now let's look at B, step 3. Our reason is substitution, so we need to find what we substitute in order to fill in the blank for step 3. So if we look at step 2, what do we have that's the same that we can substitute?
1 and 3. Wait.
2 and 1.
Just looking at step 2, what do we have? 180. That's the same in both. So for step B, we can say that the measure of angle 1 plus the measure of angle 2 is equal to, well, step 2 said it's equal to 180. So what are we substituting? The measure of angle 2 plus the measure of angle 3. Okay, so we have the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. And this, our reason, which is stated here, is substitution. So we substituted the measure of angle 2 plus the measure of angle 3 into this 180 because we know they both equal 180. So now we have the measure of angle 2 is equal to the measure of angle 2. And what's our reason for this? Reflexive. Reflexive property of equality. And the next one is the measure of angle 1 is equal to the measure of angle 3. Well, if we're going from, let's look at B up here. If we're going from this to saying that the measure of angle 1 is equal to the measure of angle 3, how do we get rid of the measure of angle 2's that we have up in this equation? If we're getting rid of something from the equation. Subtract. So we subtract the measure of angle 2 from both sides of the equal sign. And we're left with the measure of angle 1 is equal to the measure of angle 3. So what's our reason for step 5? What did we just do? Subtraction property of equality. Okay, so now let's look at step 6 with D. This is the last step of the proof. So what do we write in the last step of the proof? What we're trying to prove.
Answer, yeah.
So what are we trying to prove?
That 1 is congruent to 3.
That angle 1 is congruent to angle 3. And in order to go from saying that they're equal to saying that they're congruent, it's the definition of congruent angles. So the last example, we had the definition of congruent segments to go from the equal to congruent. So now we're going from equal to congruent, but with angles. So the definition of congruent angles. So to go to step 5 to 6, if you know two angles are equal, then you know that they're congruent. But you have to make another step, because in this one we're saying that they're equal, but we have to prove that they're congruent. So if you know they're equal, then you automatically know that they're congruent, but you just have to write that as a step and put the definition of congruent angles. So before you start writing a proof, you should plan out your logic. Sometimes you will be given a plan for a more challenging proof. This plan will detail the major steps of the proof for you. So before you just jump right into the proof, it's better to have an idea of what you're going to do. So here we have two more theorems. We have the right angle congruence theorem, which states that all right angles are congruent. So if angle A and angle B are right angles, then angle A is congruent to angle B. So if angle A is a right angle, what does it equal?
90.
And if angle B is a right angle, what does it equal? 90. So then they're congruent. So congruent complements theorem. What does it mean to be congruent? They're the same. And what does it mean to be a complement?
Equal 90.
They add to equal 90. So the congruent complement theorem is the same thing as the congruent supplement theorem, just they add to give you 90. So use the given plan to write a 2-column proof. So we have angle 1 and angle 2 are supplementary, and angle 1 is congruent to angle 3. So angle 3 and angle 2 are supplementary. This is what we need to prove. So our plan, it's supposed to be given, but it was erased. So our plan is to use congruent supplement theorem. So we see on the left side, we have our statements, and then on the right side, we need to provide reasons for those statements. So we have angle 1 and angle 2 are supplementary. Angle 1 is congruent to angle 3. What's our reason for that one? Ryan, what's our reason for step 1? Given. Next we have the measure of angle 1 plus the measure of angle 2 is equal to 180. Definition of supplementary angles. Now we have the measure of angle 1 is equal to the measure of angle 3. Not substitution. We're looking at this part of the given. So if we're going from angle 1 is congruent to angle 3 to the measure of angle 1 is equal to the measure of angle 3, how do we get from that step? Definition of congruent angles. Now let's look at step 4. The measure of angle 3 plus the measure of angle 2 is equal to 180. Is there anything we can deduct from step 2 and step 3 to get to step 4? We have the measure of angle 1 plus the measure of angle 2 is 180. The measure of angle 1 is equal to the measure of angle 3. So can we take this measure of angle 3 and plug it into the measure of angle 1? That we get? The measure of angle 3 plus the measure of angle 2 is equal to 180. And this reason is substitution. So now we have step 5. Angle 3 and angle 2 are supplementary. How did we get from 4 to 5? Definition of supplementary. Example is on, I guess, slide 13. But the 2-column proof is on 15, so we're just going to skip to 15. But if you need to go back and look at the problem, it's on 13 and 14. So we have angle 1 and angle 2 are complementary. Angle 2 and angle 3 are complementary. What's our reason? Given. The measure of angle 1 plus the measure of angle 2 is equal to 90, and the measure of angle 2 plus the measure of angle 3 is equal to 90. Definition of complementary angles. Now we have the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 2 plus the measure of angle 3. How did we go from step 2 to step 3? Substitution. Right, we took the measure of angle 1 plus the measure of angle 3 and plugged it in to the 90 because we know that they're both equal to 90. So this is substitution. Now we have the measure of angle 2 is equal to the measure of angle 2. Reflexive property of equality. Now the measure of angle 1 is equal to the measure of angle 3. How did we get from step 3 to step 5? Subtraction. We subtracted the measure of angle 2 from both sides of the equal sign. We got rid of them. So what's our reason for step 5? Subtraction. Property of equality. Now in step 6, we have the angle 1 is congruent to angle 3. Definition of congruent angles. Because if this states that the two angles are equal, then we know that they're congruent. And we know that they're congruent because of the definition of congruent angles. So write a justification for each step. Given that the measure of angle ABC is equal to 90, and the measure of 1 is equal to 4 times the measure of angle 2. So let's look at the first step. What's our reason? Given. We have the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle ABC. We have two angles that add to give you the whole angle. This was a postulate, so it's the angle addition postulate. So just think, you're adding the angles to get the whole one, so it's angle addition postulate. Now let's look at step 3. 4 times the measure of angle 2 plus the measure of angle 2 is equal to 90. Substitution. We plugged in 4 times the measure of angle 2 into angle 1. So this is substitution. Now we're combining like terms on the same side of the equation. Simplify. So when you're combining like terms on the same side of the equation, you're just simplifying. Now we have the measure of angle 2 is equal to 18. Division property of equality, because you're dividing by 5 on both sides. Last slide. So we're going to use the linear pair theorem to show that the angle pairs are supplementary, and then use the definition of supplementary and substitution. So if we have angle 1, angle 2, angle 3, and angle 4, what do we know about the relationship between angle 1 and angle 2?
They're supplementary.
They're supplementary, because this is a straight line. It's a straight line. So angle 1 and angle 2 are supplementary. So let's write that down. So we have our statements and our reasons. So our first statement is angle 1 and angle 2 are supplementary. What do we know about the relationship of angle 1 and angle 4? They're also supplementary. So angle 1 and angle 4 are supplementary. Now, how did we know that they're supplementary? Because it wasn't given to us. All that was given to us was angle 1, angle 2, angle 3, and angle 4.
They make straight lines.
Because they form a linear pair. Yep. So this is the linear pair theorem. So if angle 1 and angle 2 are supplementary, what can we put in the next step? What's the definition of supplementary?
Equal
180.
They add to 180. So angle 1 plus the measure of angle 2 is equal to 180 degrees. And then we can do the same thing for the measure of angle 1 plus the measure of angle 4. And what was our reason for this? Definition of supplementary. What's our next step? So if we have two angles that add to 180 and two angles that add to 180, what can we do with the angles? Make them equal. So what would our equation be? Sarah?
Angle 1 and 4.
So you,
Or both of them.
so you set them, remember they both equal 180. So we can write it like this. The measure of angle 1 plus the measure of angle 2 is equal to 180. What else is equal to 180?
Measure of angle 1 and 4.
The measure of angle 1 plus the measure of angle 4. Well, if the measure of angle 1 plus the measure of angle 2 is equal to 180, and it's also equal to the measure of angle 1 plus the measure of angle 4, we can just get rid of this 180. So we have the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 1 plus the measure of angle 4. What were you trying to prove?
That they're congruent, or that they're supplementary.
What does it say when we say it says prove? Robbie. What are we trying to prove? What does it say? It says prove
That they're. Oh, we done.
that the measure of angle 1 plus the measure of angle 2 is equal to the measure of angle 1 plus the measure of angle 4. So we're done. And what was our reason? How did we get from step 2 to step 3?
Definition of equal.
Substitution. We substituted 1 plus 4 into the 180. So this is substitution. And that's it. We're done.